Okay, so now we will do a few examples of geometric sequences. Let's start. So the first question is we are given the sequence, find the next term. Okay, so first let's explore and discover the sequence. The first thing I notice is that the first term over here is 5, which is equal to our a. Now, since we're working with geometric sequences, I know I won't have a common difference. I'll have a constant ratio. That means that 5 multiplied by something is 15. 15 multiplied by that same thing is 45. And 45 again multiplied by that same thing is 135. And when you work that out, you discover that that something is 3. So when we continuously multiply by 3, then this sequence takes shape. So to find the next term, all we have to do is once again multiply 135 by 3, which is very simple. That's 135 times 3, which is equal to 405. Next question. They say determine a general formula for the sequence. We know that the form of a general formula for an arithmetic sequence, not arithmetic, geometric, sorry, is Tn is equal to A times R all to the power of n minus 1. That's simple. Now we say Tn is equal to our A, which we have discovered is 5, multiplied by a constant ratio, which is 3 all to the power of n minus 1, and that is our final answer. Now let's move on. We are given this formula, 2 times 3 n minus 1 from n equals 2 to 5. Now this is quite simple. We know that this is a geometric sequence because it's literally in the formula, it's the shape of a geometric sequence, which is usually our Tn ARn minus 1. So now we just have to evaluate at all of these terms. So when n is equal to 2, then we have 2 times 3, 2 minus 1, which is equal to 2 multiplied by 3 all to the power of 1. And we know anything to the power of 1 is that number itself. So that's just 2 times 3, which is 6. When n is 3, then we have 2 multiplied by 3. We take this 3, we minus 1 from it because of our formula. So 3 minus 1 is 2, which is equal to 9. So 3 squared is 9, multiplied by 2 is 18. And we just continue that. It equals 4 to 3 cubed, which is equal to 54. And then when n is equal to 5, then we go and say 2 times 3 to the power of 4, which is equal to 162. And those are all of our values. And notice over here that from when n is 2 to 5, when you evaluate that, that's 4 separate terms in sequence. And based on this notation, we can determine how many different terms there are in the sequence by saying top number minus bottom number plus 1. So we know that there's going to be 4 terms in this sequence because we can say 5 minus 2 is equal to 3 plus 1, which is equal to 4. That will prove quite valuable later when we move on to a section known as series, which is when we start adding all of these terms up. Something important I forgot to mention in the previous video is a law or rule of our constant differences. So just as we had for arithmetic, just right here, arith, we know that T2 minus T1 is equal to T3 minus T2, which is equal to T4 minus T3. Something very similar follows in geometric sequences. So if we say geo, we know that T2 divided by T1 is equal to T3 divided by T2, which is equal to T4 divided by T3. These two properties for arithmetic and geometric sequences is very important, based on certain questions that they like to ask in different tests and exam situations.